Okay, so here's this data set. It's got 25 variables. Again, I'm just calling them y1, y2, y3, all the way to y25. You can see over here there's 108 rows in this data set. So basically I have 108 observations where 25 variables are measured on each. So the first thing you're going to notice is there's some missing values. So I'm just kind of clicking on a couple so you can see them right here. Okay, click, 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 right? So you can see I got a bunch of these missing values. And it's good practice to sort of check out those missing values. See if you can learn something about your process and this data set by examining missing values. And it's just good practice, right? There's a lot of things you have to do to run certain statistical analyses if there's a lot of missing data. So let's just get a sense of, okay, how much missing data do I have here? And there's a couple ways to do this in JMP. The basic way to do this, and this is probably what you might be doing in class to count up how many missing values, is in JMP's distribution platform. So if I go over here and I'm just going to put in all the values, what JMP is going to do is it's going to create, these are all continuous values, so variables, so JMP's going to create a histogram, box plot, and a bunch of summary statistics. Now, the default doesn't have the number of missing values shown, but if I go under the red triangle, customize summary statistics, and this is where I can change what's being displayed there. So right now, number of missing values isn't checked, but if I do click it and hit OK, you'll see that that gets added. Now, it just added it for this one. I don't know if you know this trick in JMP, but if you have a lot of, in this case, we have 25 of them. If you have a lot there, what you can do is you just hold down your command key when you drop down the red triangle and keep your command key held down. And then when I click on anything here, I'm doing and missing, hit OK, then it's going to perform that operation for all variables. So now you'll see this gets added into each one of these. Now, if you always want that displayed by default, and I don't know if you've ever done this in JMP, but we have preferences that allow you to specify things for various platforms. So I'm going to open up preferences, and I'm going to go to platforms. I already did that, that's why it's selected. And here's a list of all of our platforms. So you go to one, and I'm going to find distribution summary statistics. So these are the defaults that get shown. So if you want to change it, so if I add number of missing and hit OK, then whenever I run the distribution platform, I'll run it again just so you can see. Whenever I run the distribution platform, number of missing is going to get added because I asked for that by default. So if you deal with missing values in your class a lot and you sort of want to direct students to that part of an analysis, you can just add it by default so it always comes up. Okay, really basic way. Just wanted you to see where that is. Another way you can do it is if you go under columns, there is something called column viewer. And so I'm going to click on column viewer, and I'm just going to click on all of the variables and click on show summary. And this just basically shows some summary statistics for each of those columns. And so you see I have the number of observations, non-missing, the number missing, and then some min, max, mean, standard deviation. But that's another quick way just to get those counts of missing values. Another way to do it is under tables. You can click on this summary platform. And basically what you do is you select the variables you want, and then you pick the statistics you want to see. And so I could click on the statistics. I can say number of missing. And when I hit OK, it's actually going to send that information to a data table. And so now I have a data. I only asked for one statistic. That's just why the number of missing is the only thing there. But now I just sent all that information to a data table if I want to do that. Okay. But the more interesting way to do this is we actually have some platforms built in to do exactly this, explore missing data. So under the tables menu, you'll see this platform called Missing Data Pattern. So I'm going to launch that. I'm going to put in all the variables in there. I'm going to hit OK. And then what JMP does is it opens up this data table, creates this data table. And what it's doing is it's summarizing the missing pattern that's in the data. Okay, so the way you interpret this is, so this first row here, and I'm going to click on it. So out of all 108 observations, it's telling me that there are 51 of them that have no missing values. And when I click on that, you'll see that all of those observations get highlighted there. So for example, if I want to now create a data set that has only the non-missing observations, then I can say tables, subset, and then I can say, okay, the selected rows, subset by the selected rows, and then I'll hit OK, and then it will create a new data table, and these are all the observations that have nothing missing. Okay, I'm going to close that, get back to this missing data pattern table. So I can go through here and click on the different sort of missing patterns. So I'm going to click on one down here where there's a lot. So those rows I just highlighted, there's 25 of them. There are 25 rows that have 2 missing values, and you can either count the 0 and 1 pattern, or you can just scroll over and look. So there are 25 rows that have 2 missing values, and those are in rows, or sorry, those are in variables y6 and y11. Okay, so you can see that the ones there on y6, y11, or if you're looking at this pattern, you can kind of count over and you'll see that that's the 6th and the 11th position where the ones are and the rest of them are zeros. I have 14 rows that have 1 missing value in variable 6. So as I highlight these, remember they're all selected back here, so I can do things, for example, let's say, actually I'm going to click on, let's say I'm just going to click on these two together. So if I wanted to, I can say, okay, I'm going to put a row state of red color for all of those rows. So whenever going forward, if I make any kind of graph, those rows are going to be identified with that color across the variables where I have an observation. Obviously, I'm not going to be able to see them for the ones that are missing. So I'm going to clear row states. Okay. There's also a visual of this. So I'm going to open up this little cell plot here. So I'm going to make this the same size as that, so you can kind of see. So another way to look at it is this visual of this pattern. So I could see where those are. Okay, and I can click in there as well. Okay. All right, I'm going to close this. I'm going to continue on this exploration of missing values in another platform. Okay, this one was just to show me the pattern of where things are missing and where they're not. So under the Analyze menu, Screening, we have a specific platform called Explore Missing Values. So I'm going to launch that. I'm going to put in all of my variables here. Hit OK. And does a few things. One thing it does, and I know we already got this here from the column viewer and the table summary, but this is just showing me the number of missing observations in each of those variables. I can actually click here, and what it's going to do when I click color, whoops, I got to select all the variables first. I can pick any individual variable, but I'm going to select them all. And then when I say color cells, so you now see how every observation that's missing in this data table, I've got the color red. So this is a quick way to scan and see that missing pattern. And you should notice something, that there's that Y6 and Y11 where there's the most missing data. We can see that. You might also notice I'll hit certain points where there's a lot of missing values. So if this was data measured in time order, it seems like there's a lot of missingness that occurs at that time. Okay, so I can see that. Let me get back to the platform here. Another way to sort of see that view of the table with what's missing, what's not, is this little thing called missing value snapshot. I'm going to click on that, and I'm going to make this. I'll make this a little smaller so you can see it here. I'm going to go like that just to make it wider. Oh, it doesn't really matter. So this is a view of the data table as if I could stand very far back and look at the whole data table, and it's going to show me so there's Y6, there's Y11, there's that time period where I showed that there's a lot of missing values across many variables for whatever reason. You can explore that. So this is especially if the data table is really big and you can't view it all on the screen at once, this gives you that view. And so a question you ask when you see when you have missing value in a data set is that missingness random, or is there a pattern to that missingness? And it's clearly not random, right? We're seeing this period where all the observations are here, and then we got the two variables here and here where there's a lot of missing data. So there's something there to figure out what's going on. Why are those two variables missing a lot, and why is there a lot of missingness around this same time period in the observations? Okay, so that's kind of, you might learn something from your process just there. I find it funny in practice when I'm working with scientists and engineers, and there's missing values, and you sort of try to explore why. Sometimes it's something technical, like there's something wrong with the equipment, but other times it's actually been funny where I've come up to some engineers and I'll say, geez, I noticed on Friday afternoon there was just a lot of missing data. What happened? And I've heard things that are as kind of funny as someone said, you know what, Jacob, he's retiring. We had a little pizza party at the end of the day, and we just weren't able to make all the measurements we needed to, so we didn't get to measure all the parts that we were intending to. So sometimes it's a funny reason. But what's nice about this view is I can actually, if I wanted to, sort the data. So let's say I had different attributes in here. I could sort the data by that. And then when I look at this pattern, I can see, is there that missingness sort of a function of something? So for example, imagine I sorted this. Actually, I'll just do this just to illustrate. So I'm going to say sort. I'm just going to pick a variable y1. I'm going to put this in a new data. Okay. So I've got all this data, same data, but now I've got it sorted by this variable y1. And now if I go and explore missing values, put everything in there, and I'm going to say, show me that missing value snapshot. Now I've sorted all this data by variable y1. And let's say, for example, when I did that, it's not happening here, but let's say when I did that, all the data, missing data tended to say occur up here, then I'm like, oh, that's interesting. The missingness across these other variables tend to occur when y1 happens to be low. Or you might have a categorical variable, maybe different operator, different equipment, different day of the week, any of those variables, you can sort by it to start to see if the missingness is a function of those other variables. So it's kind of an easy way to do that. But I'm going to close this and go back to the unsorted table. Okay, and close this. Okay, now there's something I can do. Oh, actually, let me add something here. That's nice. I'm going to add this clustering, this little clustering graph. So what this is I'm actually looking at this missingness by clustering it in two directions. So going across this view here, looking at the rows, what it's doing, so as I click on any one of these, I'm actually I'm clicking on some rows here, and so I can see ones that are, I'm just going to click on, let's see, I'm going to find two that look really similar here. I'm clicking on these two rows here. You'll see what's highlighted. Okay, so that's row 51 and row 12. Okay, So those two rows, you'll notice that the missingness is kind of similar. It's not identical, so they both have missing data in variables y2, y3, and one of them has a missing value in y8, the other one doesn't. But there's a similarity there, okay? So I can sort of click on any of these and I will see ones that have a lot of commonality with the missingness. And sometimes it's more than one row. So like, for example, I just clicked on those, and so you'll see them all highlighted here. Okay, so all those ones that I've just highlighted, they have this similarity where they have this missingness across y6, y11, and then some of these rows here, and I just highlighted it. Let's see. Oh, it's two of them, row 107 and row 18. Those two rows happen to also have a missing value in y8. So this is a way I can look across. I'm sort of clustering these observations together if there's some similarity in their missingness. It doesn't have to be identical, but I'm seeing some similar patterns. I can also go the other way across the variables. And so now I've got this dendrogram on the bottom, and I'm going to click on, there's a lot of similarity here because I can see them kind of clustering together. So I just grabbed those columns there, those variables y1, y7, y10, y18, and y20. I'm going to go back to those ones to see highlighted. If you scanned down these variables, there will be a very similar pattern. In this case, I'm grabbing ones that look like I don't see anything missing. I'm going to grab another set. So here's y19 and y23. And if you notice, as I scan through, I know it's kind of moving fast on your screen, you'll notice that y19 and y23 both have a missing observation at row 54. Is that it? That one's just row 54. I'll grab another one that's similar. I'll grab this set right here. So these are variables y5, y9, y16, y25. Let's see, if I go here, you'll notice that, I'm going to scan over here. Yep, so all of them, y5, y19, y16, and y25, you might notice they all have a missing value in row 55. Okay, so in row 55, all of those variables have a missing value. So this is a way, again, you get to sort of explore, are there some similar patterns across the variables and across the observations? And you may learn something about your process in doing this, okay? Again, I'm being generic about what these variables are, but if you were intimate with what this process is, you might start learning some stuff. So this is sort of extending beyond just counting, how many missing values are there in each variable? That's one thing, but now you can expand this into a little bit more of a multi-dimensional way to view this and start matching observations and variables up to each other, okay? Now, there are a lot of statistical techniques that are kind of based upon needing observations to even run. So a common thing to do is to impute those missing values. But before I do that, and so there's this command where I can sort of impute missing values, but before I do that, let's move to looking at outliers in this data set as well. And I'll keep those highlighted so you can quickly see where the missing value is. But before I impute them, let's explore outliers. All right. Now, as you know, a classic way to do it is you can graph the data, right? A lot of simple ways. For example, I'm just going to pull up the graph builder here, and I will just throw all the variables in. What's a good view? That way. Now let's do it that way. Let me just make this a little bit bigger, and I'm going to choose to add box plots. Okay, and so this is just a way that one variable at a time I can look at some unusual observations. So here's one there, row 49. I'm seeing row 49 across. It's an outlier across many different variables. There it is there. So this is just one dimension, and we're going to need to do something more sophisticated. But this is a common thing, right? We do in the intro stat classes. We look at variables to see where there's missingness. Now, since this data is in time order, what I can do is maybe view this in a time series plot. So I'm going to plot just a little time series plot of the variable y1 there, and I am going to swap out that variable. And now I can sort of, with this same view, I can click through, and now I'm kind of looking at not only something large, but is it large? It's almost a group of observations large, right? So you might see, as I'm clicking through here, you might notice around this time period here that I'm highlighting, right, between 40 and 60, a lot of these variables tend to get large during that time. And you kind of see that pattern, then it drops down, then it goes back up. So I'm sort of thinking of this as, well, I'm kind of looking at outliers or unusual observations more as a pattern than just is one individual value large or small, but are they sort of appearing in groups? And I can kind of see that. So that's sort of a nice little view. I always like to, if I have observations like that where the order, I can plot that in a time series graph. But I'm going to open up a tool more specifically designed for looking at outliers, and this is under our Analyze screening. So explore outliers. I'm going to put all the variables in, hit OK, and there's a couple tools I can use, and I'll just start off with this basic one. So remember how we often teach in the intro stat class that we'll call something an outlier if it's 1.5 times the width of the interquartile range from those two quartiles, right? Well, I can ask for that. So I'm going to type in 1.5.25. So what this means is if this is 1.5 the distance from these quantiles, and it's going to do both the 25% and the 75% just by putting one in. So if I put in 10, then it's going to basically measure 1.5 times the interquartile range from the 10th and 90th percentile. So I know we often just teach that one basic one, 1.5 times the distance of the interquartile range from the 25th and 75th percentile. But this tool allows us to generalize that more than just the standard. So I'm going to click on that, and we get this table here, and I can see for each one of these variables how many outliers there are as defined by how I've measured this. So for Y7, it's saying there are 3 outliers, and here are those values, right? So I can kind of see those. I can scroll this over if the list is long, but it's not. And again, I can change this. So just to create a bunch more outliers, let's say I'm just going to say, okay, how many are 1.25 the interquartile range beyond those two quantiles? Hit rescan, and you see now I have a bunch more. So this is a nice tool because it allows you to generalize how you're measuring distance as being an outlier as opposed to just the standard. And then I can choose if I want to color those observations. I know we've got right now we've got these color-coded red for the ones that are missing. And what I don't know if it's actually going to pick red or not. I'll just do it with one. Well, let's see. I can always change that. So I've got all of these, and I'm going to say color cells Okay, oh, they also did it in red. So now I've got red here for both the missing and hold on one second. I want to do select. I'm just looking to see. I'm going to turn that off. Okay, and then I'm going to go back. Oops. Okay, I'm just going to go back. So the ones that are missing are color coded. I'm not color coding the outlier, but obviously you saw that I can do that as well. So as I'm exploring, there may be a way to use a different color, but I haven't looked into that, so I'd have to figure out if there's a way to make those different colors, which would be nice. It wouldn't surprise me if you could do that. I just don't know how to do it, so I won't fumble around now. But it allows me sort of to have them identified in the worksheet. So as I'm scrolling around and looking through, I can kind of see them easily. It allows me to explore that. Okay, so this is just sort of doing it one variable at a time. We've got some multivariate ways to do it, but what I'm going to do is I'm going to do this in the multivariate sense in another platform. So I'm going to launch JMP's multivariate platform. I'm going to put all the variables in here. And what this platform does, it's a pretty big piece of output here, but what this platform is doing is it's saying, okay, you've got 25 variables. I'm going to make a correlation table, and I'll close this. And then I'm going to make a scatter plot. I'm going to make a scatter plot of all possible combinations of those 25 variables. Now, I can make those bigger if I want, so I can scroll that. And of course, the bigger I make it, then the more I have to kind of scan around. But looking at this in 2 dimensions, I can certainly see some. I'm highlighting some there. And then if I want, I can choose to say color those observations. So I'm going to say color those blue. And so now in any graph, if I click off, I can see I've identified those in blue. And actually, now that I've set that as the row states, anything I do, those points will always be seen in blue. So if I go back, for example, to pull up the graph builder here, and I will do that time series plot that I had. I'll keep it like this so it's easier. They'll stand out a little bit better. And I'm going to bring that data, the column switcher back up. I can swap them all out. Okay. So now, so you see those observations sitting there in blue. Those are the ones I've identified by highlighting it in that multi-dimensional, looking at scatter plots. So I can kind of click through there and track them through across all of these variables. Okay. And it doesn't just have to be a time series graph. I could have also done that. I could have also done that if I just, for example, was choosing to look at these as a dot plot. So all those observations I've highlighted and turned blue, I can now see them individually. And this is kind of interesting. It's, I think, an important thing to teach your students, because something may not be unusual in one dimension. As you see, for a lot of these variables, things aren't unusual, but what makes them unusual is in this kind of multi-dimensional sense. So, for example, this graph right here that I'm highlighting, you know, I'm not saying they're not on the edges of those two variables, and but what makes them unusual is that they are. Let me scroll over to see what variables those are. That's y1. I'll just pick another one, actually. I'll pick this one right there. So that's observation 49. That's unusual in this dimension of y1, say, versus y5, because for that value of y5, you would expect it to be higher in y1. So it's unusual in a multi-dimensional sense, more so than just in any one dimension. You can kind of see that when you look at these observations. Well, those are kind of right in the middle. That's y8 on the x-axis. Those are right in the middle of y8. So it's not that they're unusual. It's just that they're very low in y1 for those values of y8. Or the other way around, they're much higher than you would expect in y8 for y1. So now this is allowing us to look at this multi-dimensionally, at least in 2 dimensions. Now, if this is too hard because there's so many variables, well, sometimes what I like to do is I will just make a scatter plot with any one or pair, okay? So I've got y1 and y2, and then I can bring up the column switcher, and I'm going to swap out with all the variables there. And then I'm going to bring up the column switcher again for what's on the x-axis. Hit OK. And then now what I have here, oops, sorry, I'll hit done. Got this a little bit bigger than I want it to. Hold on, let me scroll these up so I can see it better. Okay, so now I've got just a scatter plot of one pair, y1 and y2. And then what I can just do is then just pick any pair that I want to look at. So it's just now I've just got a larger view than instead of trying to see that all in the scatter plot, that multivariate scatter plot matrix, right? And so this is what's allowing me to click around and explore at least in 2 dimensions. And this is a good way to illustrate to students that things can be outliers in a multi-dimensional sense, not just in one variable. Okay, and click around. And again, I can highlight any of these, and then if I want to change the color, so every time I can track those observations very easily because I'll see it in every graph. In fact, I will do that just to. I think I was picking blue. Let's grab those blue as well. Oh yeah, so I got a bunch in blue that I've identified. Again, I can kind of go through here and find them in any pair that I'm looking at and highlight them. Now this is just 2 dimensions. So to look in 3 dimensions, which I always like to do, I'm going to bring up the 3D scatter plot. Put all those in there. Hit OK. And now I've got a 3D view, and this tool allows me to pick any set of 3 I want to see on the different axes, or I can just hit this forward button and it's just going to go through every combination, and then I can spin and rotate this around. Now those ones, you can see those ones in blue. I'll make these points bigger so it's easier to see. I don't know what it looks like on your screen, so I got the points a little bit bigger. I'll make the graph a little bit bigger too. Okay. So I can kind of rotate these around so I can start to see things that might be unusual in 3 dimensions, but maybe not unusual in any 1 dimension. And again, I can just kind of go through every possible combination of 3 variables that you can do. So I can now start to see things that might be unusual in a 3-dimensional sense, but not unusual. Maybe there's a point there. It's kind of interesting. Okay. I'm going to close that. But we have 25 dimensions, not just 3. So how can I look how things could be unusual in more than 3 dimensions? Close some of these. Okay. So, oh, actually, let me bring back up that multivariate platform. I'll do it inside of there. Okay. Under the red triangle, I've got a tool called Outlier Analysis, and I'm going to launch this one called Mahalanobis Distance. I'm going to launch that, and I'm going to scroll this over, and you're like, okay, what's that? Well, I'll go to the 3D view just so you can. Close that. I'll go to the 3D view again. Okay. So just like you can think of an ellipse in 2 dimensions, well, there's an ellipsoid in 3 dimensions, right? You can think of drawing an ellipsoid around those 3 dimensions. Well, the same thing is true in 25 dimensions, even though I can't see it. But there's still a 25-dimensional ellipsoid where the center of that ellipsoid is the centroid, the mean of all those variables. So I can simply, with a vector, measure how far away is each observation from the center in 25 dimensions. That's just the length, right? So even though it's in dimensions I can't see, I can turn those 25 dimensions into 1 by just measuring that length of the vector, that distance from the center. So here's just a 3D view. So there's a center in there, and I can measure how far each one of those points are from that center in 3 dimensions. Well, it's the same idea, except I'm doing it in 25 dimensions. So on the y-axis is plotted that length, that distance. So 0 would be right at the center. And so JMP also puts sort of this value as this idea of, okay, that distance is kind of going outside of the edge of that ellipsoid. Now remember, I colored some of those points. That's why I'm still seeing them in blue. So this is a way I now can identify. I'm just going to highlight a bunch here. So I can say, okay, these are ones that are unusual in a 25-dimensional view. I'm just going to float over to see what some of these points are. There's observation 49, right? It's not as unusual in a 25-dimensional sense, even though when we're looking at smaller dimensions, it was standing out. But if you take all of the dimensions into account, all the variables into account, it's not as it's unusual. Okay. So those are some tools where you can really explore unusual observations, outliers in more than just one dimensions in a multi-dimensional sense. And since we're in the age of where there's just a lot of data, a lot of variables, right? The age of big data, we have to kind of expand how we look at things like outliers beyond just one dimension. So I'm gonna close this up, and I'm gonna get back to the idea of missing data. Okay. Well, if you think of this data, I can look at the variation, the correlation, where things are on average, and I can ask JMP to take a guess at what those missing values are. Okay, so think of just, if I took one variable, I could replace it, let's say, with the mean and plus or minus some measure of variation, right? Just like you can think of a distribution, I can randomly select in that distribution based upon the mean and the standard deviation of that one variable, and then I can replace all those values with that. In a multi-dimensional sense, now I've got to incorporate correlation. Okay, so it's almost like you're just interpolating, right? You can almost think in two variables you can fit, like a line, and then just say, well, that's a decent way to guess where things are. So I'm going to do this in a multi-dimensional sense. So I'm going to hit this multivariate normal imputation. We've got other methods. Some of them are more advanced, might be beyond what you would do in a standard stat class, but I'm going to hit this multivariable normal imputation. And oh, you know what? Sorry, I didn't have it all selected. Sorry. Okay, so now you see how all of those missing values have now been estimated based upon the variability and the correlation inside of these 25 variables. So think again, think of a 25-dimensional ellipsoid floating in space. I can use that variability and correlation to sort of randomly guess what these values are. And you might say, well, that's really weird. Why would you do that? Well, there's a lot of statistical techniques that require having all the data. And I'm going to close this data set, and I'm going to open up a different data set so we can illustrate that. So I'm going to close this. Okay. Close all that. And I'm just going to open this small data set dealing with building a model. Okay. So this is a simple, let's say this is a simple regression problem where I've got an outcome variable y, and I've got 3 possible predictors, x1, x2, x3, x4, and x5. And what I'm going to do is I've got some things already saved, so just for the preservation of time, I'm going to do that. Okay. So this comes from the Analyze Fit Y by X platform, right? So this is just doing a simple linear regression of one variable at a time. And what I can do is I can just swap out what's on the x-axis. So I'm going to go x1, there's x2, x3, x4, and x5. So just from this, I can start to get a sense of like, well, x1 looks like it's strongly correlated, right? You can see an R squared about 73%. x2, not so much. Or I could look down here at the p-values too, right? x3, that seems to have a strong correlation. Not anything really for x4 or x5. Okay, so I'm going to keep this over here. And what I'm also going to do, I'll wait. Actually, I'm going to wait on that one. Okay, so now let's say like, okay, well, you know what? I'm going to do a multiple linear regression because I want to bring in many of these variables together. Okay, so I'm going to go analyze, fit model. Y is my response. X1 through X5 is going to be my candidate predictors. I'm going to run this as a simple linear regression. Hit run. Well, it turns out, I'm getting garbage here, it turns out there is only one observation to work with. Okay, so if you look at this data table, there's a missing one in Y. Well, actually, let's use that tool I already showed you. Okay, so there's only one observation. It's observation 2. These happen to be about predicting something about cities, but that's not necessarily important. So it's the second observation. That's the only one that has no missing values. Everything else has a missing value somewhere. Some of them have more than one missing value. Let me move this over like this so you can see. All right, so you can see that there's a missing value. Sorry, my printer is printing out behind me. Sorry for the noise. So you can see missing values. But what happens in linear regression is if there's something missing somewhere, it's going to kick that row out entirely. So in other words, I only have basically one observation to run a linear regression, so I can't fit a model. Well, JMP has a way to handle that. And it's this thing called informative missing. So if I click on this red triangle, I'm going to click on this thing called informative missing. And I'm going to hit run. And here, it's using all 20 observations. And you might be thinking, well, how is it doing that? Because you just told me that it kicks things out. Well, it's doing something kind of interesting. So behind the scenes, what it's doing is it's replacing all of the missing values for a variable with the mean of that variable. And if I ran a simple linear regression with, say, one variable, let me go back to this. If I replaced, so I've got, let's pick one of these here. I'll pick x2 because it looks like there's a lot of missing values. So you see I have a slope coefficient for x2 with all those missing. If I replace that with the mean, that coefficient isn't going to change. Okay. So JMP does two things. It goes through, replaces each missing value with the mean of that variable, and then it creates an indicator variable if there's something missing or not. Now, I did this manually. You don't have to do this, but I'm just going to, I created these columns manually so you can see. Okay. So you see how there's basically an indicator variable. Does that row have a missing value or not in each of those variables? So it replaces each one missing with the mean and sets up these indicator variables, and now it's basically fitting all 10 of those into a model. And so this is why if you look at sort of the output, and I'm going to open this one up here. Let me close some of this. First, I'll point out, look how high the R squared is there. I'm going to close this up. I'm going to close this up. And I'm just going to open up this table here. So basically, here are all the parameters being fit in the model. You've got the intercept. You've got x1, where it's replacing the mean if it's missing. And then the indicator x1, is it missing or not? So you see for each variable, I've got a variable with the mean replacing the missing, and an indicator variable saying, is it missing or not? Now you don't have to create these ones I created. This is being done automatically, but I just did this because I'm going to show you a graph of what's going on. So if you look at this, I can do a statistical test for each one of those pairs. Now what I'm going to do, and then up here is sort of the total variable, you know, with the whole concept of the slope and the indicator. I'm going to take the one for x2 out. In fact, because you can see it, that's not significant here either, so I'm just going to remove that out. But everything is significant, x1, x3, x4, and x5. And you might be looking and you say, wait a minute. I'm just going back to the one variable regression. I remember x1 was significant. I remember x3 is significant. But I don't see how x2, x4, x5 could possibly, well, sorry, I took out x2. I can't see how x4 and x5 are significant. That's really weird. In fact, this one for x5 has the most significant p-value. That's really weird, okay? So here it is down here. x5 is missing, has the most significant p-value. So you're like, this is really strange. Now notice, x5 with the mean replacing the missing value, that's not significant. So in other words, the slope isn't significant. So this picture on the left, that slope isn't significant. Same thing with x4. Oh, did I just lose it? Where did my x4 just go? Oops, whoops, I lost it. Let me bring that back up again. Okay. So same thing with x4. The slope isn't significant if I replace all those missing values with the mean. So you can see that right there, not significant. But the indicative variable of x4 missing or not is significant. So basically what I picked up is I've got the x1 slope significant. Right there. I've got the x3 slope significant. Right there. But I don't have the indicator variable of if x1 is missing or x3 is missing significant. That's right there. And right there. But now I've picked up two terms in my model, x4 missing and x5 missing. And to illustrate what that is, I'm just going to pull up a graph. Okay. And basically, I'm going to see if I can get all these two on the screen at the same time. Get this here. Actually, I'll just show the graph is probably all I need. Okay, and then here is that complete regression output. Let's move these around so you can see them all together. Okay. So what does it mean that this variable, this indicator variable x4 missing or x5 missing is significant? What did it find there? Well, I'm going to illustrate this because I created this graph manually by plotting the response variable on the y-axis versus just this indicator variable, is it missing or not? Remember, I kind of manually created that right there. And if you don't know how to manually create these things, you basically just create this formula, you know. So if the variable is missing in x1, put the word missing, else put non-missing. So I just manually created those. Again, to run this informative missing, you don't have to do this. I just did this so I can illustrate with this graph. So let's take a look at x4, whether something's missing or not, and x5, whether something's missing or not. Now, you can see from just the graph, but I also put up the hypothesis test. It's basically a two-sample t-test right up there. And so you'll notice that if something is missing in x4 or x5, the values for y seem to be very different. So that's what sort of the idea of this concept of missing, informative missing. There's some information in the concept that something's missing. And again, you can kind of investigate to figure out why. So not only can we kind of explore missing values, but we can actually build a model preserving the fact that there's something missing and can explore that concept of missingness. And then this allows us to fit a full model, basically. Because remember, when I tried to run a multiple linear regression, I didn't have anything. I just had one data point. Now I can actually fit my multiple regression model. And again, I have all these parameters that I've now fit, something being missing or not, as well as the slopes. Okay. Now I'm going to close these up. Now we have some platforms that sort of do that missing automatically. And I'll finish up by just showing this one last platform here called partition. Okay, with all the variables. Now, if you're not familiar with partition, basically, you see right here, I've got informative missing clicked on, so it's kind of on by default. So I'm gonna hit OK. If you're not familiar with partition, what it's basically going to do, it's going to take all the data. Okay, so I got 20 observations here. The y-axis is the values of the variable y. The x-axis is just kind of spreading out the data, just as a way to group it. That line right there in the middle is the mean. So I got 20 observations, right? Here's the mean of y, standard deviation y. When I hit split, okay, JMP's going to scan through all the variables, x1, x2, x3, x4, x5, and find the place where can I split the data such that I cause the biggest difference in the mean response. And so it's basically saying that if you split x1 at the value 18, then you create the biggest difference in the mean. So there's 15 observations that are these right here. There's 15 observations that have a value of x1 below 18, and the average of those 15 observations is 14,351. And then there are 5 observations that have a value of 18 or higher for x1, and the mean of those is 24,291. So it's almost like, where is the point that if I cut the data in half, I would get the biggest significant result in like a t-test, is basically what's going on. Where are the means different relative to the within group variation? And it's scanned through all these x1, x2, x3, x4, x5. Okay, so what did it do with the missing values? Well, what JMP did is when it split here at x1 equal to 18, okay, now there's 2 missing values in x1. So what it did is it said, well, what if I put those missing values into one of these groups? Let me measure that effect, that difference. What if I put those missing values in the other group and measure that effect? And then when I have found where I can make that effect the largest, that difference the largest, well, then those are the places I threw those observations in, okay? So those observations, I'm going to highlight these right here. That's rows 13 and 16. And so there's row 13 and 16. And basically what it's done is it's found out that I can create the biggest differential in the average response when I split at 18 if I took those 2 missing values and threw them over in this leaf over here, x1 less than 18. And so as I split, it's kind of doing that process. It's finding where to split again. So here it's taken the 15 values where x1 is below 18, and now it's split it by x3. So is x3 equal to or greater than 14 or less than 14? That creates the biggest difference in these means. Now I'm going to go look at x3 and where are things missing. So I'm just going to highlight them. So there's 4 observations missing in x3, and there they are highlighted right there. And so it put them all, it put 3 of them. Oh no, sorry, they're all in that x3 less than 14. Okay, I couldn't see that at first. So now it's put those observations that are missing, it threw it into that bucket because that's where it's found the biggest difference. So informative missing is built into this partition platform, and you have to turn it off if you don't want it to do it. But again, it's another way to say, well, what's the most likely place it probably is, because it's using the information from the split to figure out where those most likely would have been. And so it's another way to preserve the missingness. Okay, so we're at the end here, and hopefully you picked up a couple tools, some things that are just simple, like summarizing the missing patterns, finding values that are missing. You can impute missing values. You can build models with missing values through this tool called informative missing. Got a bunch of ways to look for outliers in a one-dimensional sense, in a multi-dimensional sense, whether you're doing it graphically, whether you're using some of these tools like Mahalanobis distance. So I don't know. Hopefully, this has given you some approaches to incorporate this into your class, where not all is lost if you have missing values. JMP's got some ways to, whether you build in with this informative missing or you impute them. So I could have also done that, but there's not a lot of data here, so the imputing I didn't want to do. But when you got a big data set, then imputation is actually a pretty nice way to go, and then you preserve you preserve all the rows.